So now I'll talk about this Titan discovery. So I threw in a couple of different slideshows here. So I just gave this at a geoscience talk. And so here you're looking over our X-Men, and our Titan is over here in the discovery in the background. But the idea is that you can see how the hills are quite rolling. But yeah, the place got really hot there this summer, and we had quite a few fires blow up. But it's a nice country to work here. And the cool part about this Henderson Creek is we have roads everywhere going through this. So we found about at least 4 or 5 new showings this year within 50 meters of the road. So here's our Titan right along here. Here's Henderson Creek. And here's a bunch of our discoveries of our different showing areas that we're working on. Here's our Vertigo. So it's about 15 kilometers away, but it's quite close to the road, within a couple of kilometers. So I'm going to break you down the science of it. Like, what is the Titan? We don't quite know yet, but we're kind of getting an idea. But the idea is that here's our soils and geology map. And I won't get too complicated, but I'll show you patterns, and that's kind of what I work with. I'm just a prospector. I've been doing it for 25 years, but really what it's all about is pattern recognition. So here's the gold soil map. And you can see the different, basically, different numbers. So the idea is that these are the lower numbers. We start at around 90 percentile. So I just take all the data that we have and you do statistics on it. So I call it unbiased science, because it's the statistics that'll point you in the right direction. So here what you see is this northeast trending or at least northeast trending gold anomaly, soil anomaly, and you have this northeast trending system. And here's where our holes that we poked in the Titan, and the discovery hole was this guy right here. And so now I'm going to show you kind of why the first hole missed and why we hit on the second hole, and what do we think it might be. So the interesting part about this Titan was it's massive magnetite. So magnetite is pretty easy to spot, especially with the geophysics. And so here we have as a ground geophysics as a background, again with the soils. And the first thing you can see is that this oval shaped, and here's where the magnetite bodies are. We could see at least where the more richer magnetite zones. And so now when you start looking at these, the idea is that these are all represents Titan style targets. But this is a different, and I still think this is going to be really good. So that's why we can't really discount just because we hit it with a high magnetite. We know we have gold there, but there's going to be some nice structural prep here going on that'll actually, there's a high probability we got some nice gold there too. There's a forward-looking statement if I heard one. So here's these magnetic features again. But the interesting part about this is when I line up and just add up how many meters, when you stack these end to end, how much distance can we get out of this guy? There's over almost a kilometer, almost 3,000 feet of linear magnetic features here to work with. So that's the intent for next summer, is we're probably going to go in, and we're still trying to figure out how we're going to do this, but we're definitely going to be starting to bring the diamond drill in here. Whether we poke 2 or 3 holes per target, it'll be something like that, because we'll walk into it calmly. Let's not go in full blast. Let's kind of do this systematic, because we have the whole next season to work this. So that was because we drilled this right at the end of the season. Now we'll have time on our side with this discovery, so we can drill it earlier on, wait for assays, come back in for a second round. So here's this cool geochemistry, soil sampling, and what you see here is this nice northeast pattern and this nice north trending thing. And the gold that we're finding here is associated with copper. So having copper in your system, but you can see how that anomaly is covering, like this copper is scattered throughout this nice oval shape, but you definitely see these linear trends, and that's what's part of the key here. You use other geochemistry elements. This is bismuth. Again, you see this beautiful northeast trend, and again, you see this north trend. So, and again, the copper, or the gold is associated with copper and bismuth. And then of course it's magnetite, which is higher in iron. So you can see how this belt is lighting up here. And you can even see this nice linear trend in here. Even though it's off from this magnetic feature, we're still definitely got to go in to look at this. And again, you can see how this northeast trend is lighting up. I just threw in this is calcium because we might be, like, we're not sure if this is skarn type yet. Like that could be one possibility with the magnetite. And so having the copper and bismuth, sometimes it's related to skarn action, and such as the high grade. But again, you can see where this limestone units are sitting, and you can see this big front sitting on the other side here. So anyways, these are kind of the different ways. And here's the government. They had a geology map, and this is where they mapped their limestone. So you can see it's a little bit more than what they just mapped. This is what it looked like inside. Like once we went and dug the Titan. And this is where they pulled that 100,000 parts per billion. Ends up it was 113 grams in soils. So when we ended up taking a little dig, a little trencher, mini excavator, we could see, here's one of the contacts, but you could see this was all massive magnetite. So it was, so that's kind of what kicked basically in those, rocks 100 to 600 grams came from this area. So here we are before we even started digging. That was the original pit. But you could see when we went in a little bit further down the trend, right in the mag anomaly, you're just a couple of feet below surface. So that's where we would have soiled, and you could see this massive magnetite, like this is all decomposed. So, and that's what's kind of interesting. We still haven't done the thin section samples on this yet, on the rocks yet, but from what we could see, the gold is, well, we're seeing lots of VG in here, but it's liberated also because that's why we're getting such high soil assays. It's actually fallen out of the magnetite. This is what some of the hand specimens look like. So these were some of the rocks that kicked from 100 grams all the way up to 600 grams. So, but you can see this is pretty well, almost massive magnetite here. So this is kind of how I'll show you some of the science, how we kind of went in to tackle this Titan, So here's this IP survey that we do. This is a different IP survey. This is from the environment world. This is 3-meter electrodes, as you see. I just wanted to give you an idea of how it looks like in the bush. And we read with this receiver. But our resolution, because most IP surveys historically were done on 25 to 50-meter electrode spaces. But your cube of measurement is usually half of that. So if you're 50 meters, your resolution is 25-meter cubes. But at 5 meters, it would be 2.5-meter cubes. Hence, I could see very small structures coming up through the ground. And then we tried this other kind of cool, this is an old system called VLF, very low frequency for the submarine stations. But it's the idea is it's a one-man system. And this is the VLF here, and this is the magnetometer that he's got in front of him with a GPS above. And he just walks and takes readings every 5 to 10 meters. And then we take this cool program here that was designed out of Portugal, out of the university there. And they basically, we could invert the data. And that's what's the kind of, this was a fairly big breakthrough from us from an exploration point of view, just because we were able to model the structure so good and so, well, cheaply and effectively with a one-man survey. So now we have about 3 or 4 of these guys that we could throw out of the helicopter, and they could cover roughly 3 to 6 kilometers a day, depending on the nature of the topography. So this is just to show you, here it is again, here's our Titan. And you can see that nice northeast trending soil anomaly. And here's our soils on top on a plan map looking down. And the idea is that you look under, and sure enough, you can see this structure. You can see which way it's dipping. So these are 2 different lines. So you can see from line to line as it's going up through the soils. So that's why now there's it's almost an extremely high probability that these soils are related to this crack. So now we actually know which way to drill when we come in here in the spring. And that's a big, basically a breakthrough, because you could be, well, think about it, you could be sitting right here drilling here and you'd miss that. So the idea is now we have a picture of where to drill and how to drill it. So this is here's a table I made, and this is an interesting one because the nature of this gold. So here's the gold grades coming through, and here's the meterage on this side. So the big thing that we're trying to figure out is what is actually, is it 6 meters at 72 grams? Is it 12 meters at 37? Where do you put the cutoff? Because we hit gold all the way down. And so some people were questioning, because it was an open wrap hole, could there be cross-contamination, basically, because when you drill through this, you bring back the dirt through it. So we debugged this through the geophysics, and this is what I'll present. So now you can see that you're getting some nice hits. This background is the actual mag data that's called inverted. So this is showing you the magnetite body. So the interesting part is you could start to see this all the way down to the 60 meter mark, which is, you know, if you use that calculation, forward-looking statements here, but 48 meters of just under 10 grams. So is it really that far? These are low-grade hits, but so that's why everybody liked this one to stop it at 2.5 grams. So that's at the 33 meter mark, and we get at basically the 39 meter mark, you get another 0.7 hit. So, but I believe it's part of the same unit, it's just lower grade. But that proof will be approved when we diamond drill this next year. So now I'm going to show you what the inversion looks like. So here's the geophysics, this mag, ground mag. And now when they invert it, you could actually see where we drilled, and you can see where this magnetite body is. You can see where there's another one here, and you can see there's more magnetite probably in this section. And here's actually a cross section. I'll show you this one again. It's a long section, so it looks straight. It's going north-south. But you can see that here's the 60 meter mark. That it potentially makes sense that the ore, like that there is basically, that's part of the same system, like it's part of the same unit. And this is kind of the proof in the pudding. Here's the resistivity from the IP survey. So that's a different measurement because we were using mag on the other one. This is resistivity from the IP survey. And again, you can see this resistivity low unit sitting right in here. And there's the contact. There's the chargeability from the IP survey. What it does is it charges the particles. Again, it's a different science. And again, you can see this body of high chargeability that's basically related to this resistivity low area. And again, you can see this nice, you can see where the higher grade section was. Here's the VLF. Now VLF, this one, it's a different coupling. I would have liked a better one coming from the south. It's a whole other science, but again, you can see how this body is sitting here. And again, what we were trying to get is VLF to give us a dip, but you can see this kind of EM basically body in here. And the idea is that this is the way they drilled, and that's how we use this VLF again, but the VLF is picking up something here. So here's the long section just to show you again. What I did here is we're looking at it like this. Now I'll go north-south just to see what this pod looks like. And here you could get it again. So now we're looking across it. There's north that direction. And then you can see there's your, right down to your 60 meter zone. But you can see this zone continuing down at depth. And now you can see this other pod breaking out, like coming up. So it's kind of cool. And here's I just threw this for calcium from the research talk I gave, because, you know, this could be part of it's a limestone unit, and it could be part of what's going on here. So here's copper, and this is how we scrutinize our data. You use different elements. So again, what you're seeing here is this copper anomaly in the drill holes is associated right up to that 60 meter mark. And I put this down at depth because we're getting more gold kicks down here, lower grade. But I think it's going to be like it's showing that there's different zones. But this is where our better grades, of course, were up in this top part. But again, here's resistivity. So you see how it worked perfectly on this contact. So that's for sure, that's a unit going on there. Chargeability, again, mimicking it perfectly. So when you get these kind of correlations, like these are quite, it's telling you there's something like you can start believing in the science. So here's copper with the VLF again, showing you how it's lighting up on that zone. Then I threw some other elements, just again, tellurium. You can see how it's holding, but you can see this spike down at the bottom here. And that's kind of what I'm getting at. That's spiking with the gold. So I believe this is another lower grade zone down here. Again, lighten up with the resistivity, nice. So, you know, these correlations are like proven, each element is proving each other. That there's something going on for sure down to the 60 meter mark, and there's a high probability down to the 80. Bismuth, again, it's correlating with our gold, and you can see it down here. You can see it at the contact again. So, yeah, this is kind of the way we try to explore. I call it unbiased because she's basically dictating what she's finding here in Mother Nature. Here's all these moly hits, and again, I point down to this one because we're getting moly associated with the gold. So is this guy real down here? I think it is. It's lower grade, but the point is we're seeing it all the way down to there. It's different on these resistivity maps because it'll be a little bit different for why it's a different unit. But the mineralized moly is following the gold pretty well 1-to-1. So that's pretty well it from basically the talk of the Titan. But it's kind of like I say, it's the Yukon, the land of golden opportunity. Because like the reality is if this was anywhere else in Canada, we would have basically been we'd have been working this a long time ago. So it's so where are these grades? Like I say, we announced 6 meters of 72 up to here, you know, but you guys can do the math yourself. But like I said, when we dive and drill this next year, we'll get the hard rock in our hands because RAB is chips. And so but from a geophysical standpoint of view, it looks like a nice target. It looks like it's going to depth here, at least down to the 60 meter mark here. So thank you.